Okay, we're going to be doing lead code 141, linked list cycle. So this is essentially asking us to detect if a linked list has a cycle. Given the head of given head the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Okay, I think, yeah, this, we don't need to worry about this. So there are two ways of doing this. One, we can use a set, whereby as we iterate through this linked list, we add the head to the set, and as we're adding, we check if we've seen the head before in the set. If we have, then we've obviously hit a cycle, because if we're seeing it in the set already, then it already exists. So otherwise, if we haven't seen it before and we do not return, then we simply add that head to the set. The other option is to use what's called Floyd cycle detection algorithm. And the way Floyd cycle detection algorithm, the way it works is that if you have a fast and a slow pointer, and by a slow pointer it means a pointer that moves one position at a time, and a fast pointer moves two positions at a time, it means that the first pointer at one point is going to get past the slow pointer, but at a certain point in time they will be at the same position. So when this point in time arrives, that's when you know you've detected a cycle. But if it doesn't arrive, then the first pointer will hit none first, right? The first pointer will hit none first. And how do we know that? Either first will be, so you have to check for both first and first.next, right? You have to check for both of them. So let's first do the first one, right? So the using extra space structure of a set. So we'll call this store is equal to set, right? Then we iterate through the linked list, checking if the head exists in the set. So obviously initially it's empty, right? So, but what we do is we say while head does not equal to none, right? We check if it exists in the set, right? I think, yeah, we could have a base case here just not to waste our time. If head is none, then we simply return none. We return false. It means there's no cycle. So we check if head exists in set, right? So if head in set, then we simply return true. A cycle has been detected. Otherwise, if it doesn't exist, we add it to the set. So we say store dot add head. I tried using head.val, but that doesn't work. Just the head. That's what you need to do. Then we increment. Oh, sorry. We needed to initialize. No, we don't need to initialize those pointers. So if this while loop terminates, it terminates when head is none, right? So if it terminates, then we simply return false. There's no cycle because this loop this loop reached this condition. This loop terminates in two conditions. If we find a cycle, in other words, if we find a head node already in, then it means we're seeing it again. Or if head reaches none. So let's see if this works. If head is not iterable, if head I made a mistake here. We need to increment head. Head is equal to head.next. So that is it. If head is in set. Oh, I said set. Sorry, I should have said store. This should work. Yeah, sorry, this should have been store. My bad. I'm a bit tired. So when we submit this, it works, right? So this takes O(n) time, n being the length of the linked list, and O(n) space, right? So then the next one is called the fast and slow pointer method, or Floyd cycle detection method, or hare and tortoise. Because the hare and the tortoise, the hare is much faster, but it eventually, if it goes past the finish line and comes back again, at some point it will be at the same point as the tortoise, even if it overtakes the tortoise. So if head is none, we simply return false, right? There's no cycle there because it's none. So we create our fast and slow pointers for cycle detection. So slow is equal to head and fast is equal to head.next, right? Then some people use just initialize fast to head, then make it jump twice, but we're doing head.next because we want to. I'm going to show you why. So then while fast, we always use fast, right? Because it's ahead, right? While fast is not equal to none, and fast dot next does not equal to none, right? You need to check for both conditions, fast itself and fast dot next, right? Because the fast and slow pointer may come together, right? They may come together before fast.next is none, yet fast.next is none. So you need to check for both, right? And then now we check if there is a cycle, right? So if slow is equal to fast, then we simply return true. We're at a cycle. Else, we're not at a cycle. We move our pointers forward. So we say slow is equal to slow.next and fast is equal to fast. Remember, .next. It moves forward twice. If we get out of this loop, it means that we haven't found a cycle, but we've come to the end of the list. So return false. There is no cycle. So let's run this and see. Voila, this works and it's faster than 90%. Some people prefer to do it this way, where they say while fast does not equal to slow, right? Then we check if fast does not equal to none and fast dot next does not equal to none. Then you return. Actually, better not to even think about this solution because it's just confusing, honestly. It's the one used here, right? So if first is none or first.next is none, then you return false, right? Because here it will be or. So better to think about the first one that I provided. So that is an ON solution in O1 space, because we don't use any sets or anything like that. So that is the solution, and thank you. Bye.